In this problem, there's a lot we can deduce, like that these angles must all be 60 degrees, this must be 120 degrees, and these angles must be 30 degrees, but really we don't need any of that. Let's start with this triangle. Notice we have two congruent angles. Well, the base angles theorem says if a triangle is isosceles, then its base angles are congruent. Well, here we have some base angles are congruent, so we'll use the converse of the base angles theorem, which says if you've got two congruent angles, then you have an isosceles triangle. So these two sides are the lengths of our isosceles triangle. They're congruent. Next, let's focus on this triangle, which is equiangular, three equal angles. Well, if it's equiangular, then we know that it's also equilateral, so the sides will also be congruent. So all the sides will be the same. That means, by the transitive property, y plus 12 is congruent to 3x minus y, which is congruent to 5y minus 4. They're all equal to each other. Now we can subtract 12 from both sides. Next, subtract 5y from both sides. And then finally divide both sides by negative 4. And we have y is equal to 4. Then we can use y equals 4 to show that this side is 20 minus 4. And that happens to be equal to this side, which is 3x minus 5. So we'll simplify. Then we'll add 5 to both sides. And finally, we'll divide both sides by 3. And there we have it. X is 7 and y is 4.